All around us, something amazing is happening. Plants and flowers are starting to talk back.
Hello?
Someone just watered me. It wasn't quite enough.
And they have incredible secrets to share. In their fight for survival, some plants seem almost human. They help their neighbors, build relationships, and love to show off. And when times are tough, they trick, steal, and even kill. Welcome to the bizarre, romantic, and sometimes violent world of sex, drugs, and plants. Early morning, a trembling patient races into ER. Anaesthetist Monica Bermelin is about to perform a very unusual experiment. Her patient today is a houseplant, a supersensitive mimosa. The slightest touch makes its leaves spring shut. Normally that's a defense against insects, not hospital staff. Monica's challenge is to stop the plant moving. Instead of a drink of water, the plant gets a nip of ether, a knockout drug. After an hour, it's time to test the result. There's not a flicker of movement. The mimosa seems to be out cold. Ether stops nerve cells transmitting signals. It was an early anesthetic for humans. But plants have no nerves. So why has the drug worked? The answer might lie in a cage at the University of Freiburg in Germany. Professor Edgar Wagner wants to see if electrical signals pass through a plant's body. This plant's going to get a shock. Electrodes connect the plant to a computer primed to record the faintest electrical signal. The professor burns a leaf to see how the plant reacts. The computer comes alive. The scalded plant produces a faint but definite electrical signal. A 50 millivolt charge races across its body and down its stem, passing through the same tiny tubes as its sap. It surges forward like a human nerve signal, but 1,000 times slower. The plant might not have felt pain, but it definitely reacted to the flame. Tests suggest it's electrical signals which trigger a mimosa to flinch. When the plant's doused with ether, it stops transmitting these signals and sends it to sleep. Electrical activity changes in a flower stalk before it blooms. And when wilting plants are watered, similar signals race from their roots to their leaves, as if to say cheers. These tests prove one thing: plants are full of surprises. especially when it comes to their diets. Most plants get the minerals they need from the earth. But some live in places where that's impossible. They've developed an appetite for meat. The bright flowers peering between the lilies hide a dark secret. Yellow bladderworts float in water, which doesn't provide as much nourishment as soil. They need an extra bite to eat. To a hungry water flea, the bladderwort's maze of leaves looks like the perfect place to find lunch. Unfortunately for the fleas, they are lunch. Bladderworts are the fastest carnivorous plants in the world. Their traps open and close within 15,000ths of a second. One touch of the trigger hairs around the trap is all it takes. The plant sucks up the flea like a vacuum cleaner. Digestive juices dissolve their prey and give the plant its fix of minerals. But the bladderwort's appetite is small fry compared to a distant relative. In the Borneo jungle, ambush killers prepare for a feast. A trail of termites hunt for food. It looks like they've hit the jackpot. A juicy plant dripping with nectar. The front runners make off with a takeaway. But they're the lucky ones. The termites have been lured to a non-stop eating machine, a white-collared pitcher plant. One by one, they slip on its nectar and tumble into the darkness. A fatal pool of rainwater and digestive acid greets them. For the pitcher, it's the start of an endless bug buffet. It can eat over 6,000 insects an hour. Bugs living here tread a perilous path. There are pitcher plants everywhere they go. Some hang around in trees, others lie in wait on the ground. All use similar tricks to tempt prey. Every pitcher is a slippery death trap. But not all plants wait for food to fall in their laps. Some go out hunting and use the most unlikely skill to do it. This grasping tendril is cuscuta, or strangleweed. It's a neighbor from hell. Adult cuscuta have no roots. They steal everything they need from any plant unlucky enough to cross their path. When it finds a target, cuscuta lunges like a vampire and sucks out its nutrients. Once fed, This ravenous parasite spreads like wildfire. It grows up to 12 centimeters a day. Scientists at Pennsylvania State University are eager to unravel Cuscuta's secret. How does it find its victims?
The thing about Cuscuta is that it needs to locate the host quickly, otherwise it will die. But nobody knew how Cuscuta finds its host.
Some scientists think it's drawn towards water or light near other plants. But the Penn State team have an incredible theory. They think Cuscuta has a sense of smell.
We had several hypotheses, but our favorite hypothesis was that it was using the scent of the host plant.
To test their theory, they plan an unusual aromatherapy session. Their lab becomes a perfume parlor. The chosen scent to try and tempt the creeper is tangy tomato. But will Cuscuta be fooled? Or will it reach for the real thing, a tomato plant whose smell is masked behind glass? The picky plant seems hesitant. Not for long. The team are right. Cuscuta likes what it smells.
I think Cuscuta has this really sort of sophisticated foraging behavior almost that sort of defies people's expectations for a plant. It really is sort of a behavioral response that's more what we expect to see from an animal.
When it needs to find food, Cuscuta seems more like a python than a plant. And hunting isn't the only animal-like behavior plants employ. When it comes to reproduction, they pull out every trick in the book. A flower meadow is a beautiful sight. But it's not for the benefit of our eyes. It's all about reproduction. In order to pollinate, most plants need to attract insects. That's where flowers come in. Bright petals are like a neon sign above a fast food restaurant. They tell insects there's a nectar banquet on offer. Some flowers dish up their treats like canapes. To make sure insects hit the spot, lines on petals act like lights on a runway. But some flowers rely on a different kind of pulling power: raw sex appeal. For bee orchids, looks count for everything. Amorous scallard wasps are looking for love. They seem to have found a perfect partner. A flowering bee orchid looks just like a female wasp. Even its hairs feel like the real thing. In a frenzy of passion, the wasps struggle to mate. A confused courtier gets more than he bargained for. A package of pollen sticks to his head. Desperate to try his luck elsewhere, Romeo plays the field. He tries again with another temptress, unwittingly delivering pollen in the process. Bee orchids don't just look the part, They produce a perfume identical to the pheromones of female wasps and bees. The scent drives males so crazy, they often prefer the flowers to the real thing. But one plant needs to attract a far less fussy crowd. And nothing draws scavenging bugs faster than eau de toilette. Natural history filmmaker Karl-Heinz Baumann needs a cast-iron stomach. He's tracking one of the most pungent plants on the planet. The skunk cabbage smells of rotting flesh and excrement. Through a thermal imaging camera, Karl-Heinz can see the cabbage warm up for the main event. The heat helps propel the plant's fecal fragrance across the swamp. As the stench hits the fan, scavengers come running. The bugs think they've hit pay dirt. Instead, they walk into a trap. The plant walls are slippery. The bugs slide deep into its belly. But the cabbage doesn't want to eat them. It keeps its captives warm and well fed. The plant's rotten ruse becomes clear in the dead of night. With a special lipstick camera, Karl-Heinz watches a bizarre transformation take place. The cabbage's flower bursts into life. A shower of sticky pollen covers the captives like confetti. As dawn breaks, Karl-Heinz can see the prisoners are still alive and desperate to escape. They climb the stamen to freedom. Free they may be, but the bugs don't seem to relish fresh air. They rush straight to the next cabbage to innocently deliver pollen and spend another night in a stinking cell. Some insects are a plant's best friend. Others eat them alive. The question is, who's friend and who's foe? On the east coast of Mexico is a stretch of coastline called Playa Zicatela, the beach of thorns. These razor-sharp spines are the acacia tree's first line of defense. They're great for keeping hungry animals away, but no use against rampaging insects. Ants can't leave the tree alone. They've even set up home in the thorns meant to protect it. The hollow barbs are dry and cool. The perfect place to raise ant families. The great ant takeover doesn't end there. Adults rip the bulbs from the acacia's leaves. They are packed with vitamins and a tasty treat for their young. But the ants only eat the bulbs, and that doesn't harm the tree. Living in the thorns does no damage either. In fact, scientists have discovered that far from being a problem, the ants protect the tree. A simple test shows that when the tree is damaged, it cries for their help. It releases chemicals into the air, which brings the residents racing to the rescue. This may be a false alarm, but the tree's real enemies are never far away. Left alone, the grasshopper could gorge on leaves. Thanks to the ants, it won't get the chance. No one is going to trample on their turf. They bite wherever it hurts most. The ant and the acacia are perfect allies. The ants guard the tree. In return, the acacia provides first-class accommodation. There's even a minibar, pools of sugary sap. All uninvited guests are dealt with severely. Even sugar grains are treated like trespassers and are given the boot. The acacia's not the only plant with a sophisticated defense strategy. Some resort to chemical weapons. The Utah desert is a tinderbox. Temperatures climb as high as 47 degrees centigrade. Summer lightning strikes cause huge fires. The flames destroy everything in their path. But they also spark the arrival of a deadly weed. Chemicals in the smoke rouse wild tobacco plants from their slumber. The desert becomes a smoker's paradise. Hungry insects are first to roll up. They are desperate for fresh food and gobble as much as they can, as fast as they can. But suddenly, the tobacco break is over. The bugs quit in a flash and vanish. Somehow the plants have fought back and won. A group of scientists studying natural defense systems are on a mission to unravel the tobacco plant's secret. They break down a leaf sample to find its hidden ingredient. Their discovery won't shock anyone who's read the warning on a cigarette packet. Tobacco plants under attack pump their leaves with a toxic poison, nicotine.
And a leaf this size can have on the order of 5 to 10 milligrams of nicotine, which means that it's the same amount of nicotine as between 8 and 10 cigarettes. Now, when you're eating a leaf that has that amount of nicotine in it, it turns out to be a very poisonous meal. And typically what happens is that the insect will start going into paralysis its muscles will begin to tighten up, its breathing will stop, its heart rate will go erratically. It's a very potent poison.
Little wonder insects quit the evil weed. The plant may have won the battle, but it hasn't won the war. As the sun sets, the ground gives birth to a tobacco plant's worst nightmare. A tobacco hawk moth. This creature comes with a warning of its own. It can seriously damage a tobacco plant's health. A few pumps of its wings, the mighty moth is ready for action. In the darkness, scientists wait for the hawk moth's arrival. The first thing the moth wants is a cool drink. It siphons drops of dew trapped in the tobacco plant's flower. Now, it's ready for work. Adult moths don't chew tobacco, but their children do. The moth peppers the leaves with eggs. Hawk moth caterpillars hatch within a week. And they really are addicted to tobacco. They can eat more than their own weight every day. The plant floods its leaves with nicotine again. But it's no good. Hawk moth caterpillars are immune to it. The time's come for Plan B. Under siege from invaders, the tobacco plant sends out a last-ditch SOS. A smell worse than a week-old ashtray wafts from its leaves. Right on cue, the cavalry arrives. Big-eyed bug. Big Eye has an addiction of his own. Hawk moth caterpillars. And thanks to the plant's scent alarm, it knows just where to find one. The caterpillar has sharp teeth and looks ready for action. But it's no match for Big Eye's arsenal. The hungry bug gets its first fix of the day. Wild tobacco combines poisons, alarm calls, and bodyguards to fight insect attacks. Once they've managed to grow, found food, welcomed the right insects, and got rid of the wrong ones, plants have another huge hurdle, giving the next generation a head start. And they save some of the most spectacular skills to do it. Most parents don't want their children living with them forever. Plants are no exception. They need to spread their seeds as far as possible so they don't steal precious space, water and food. Some, like the dandelion, simply pack their kids off with the wind. Other plants hope their youngsters catch the first ride out of town. Bristles, hooks and sticky hairs help hitchhiking seeds get a good grip so they can travel a great distance. Unless they're discovered first. Some plants take a mechanical approach. The erodium seed sits at the tip of a tightly wound corkscrew. It acts like a motorized drill. The seed stalk is dry, but moisture from the soil kick-starts the engine. It causes the corkscrew to unwind, helping drive the seed tip into the ground. Other plants have much more explosive personalities. Violet flower seeds are crammed into a special pod. As it dries out, the pressure is intense. Eventually, something's got to give. Touch-me-nots are even more highly sprung. The slightest contact triggers a chain reaction. Seeds light up the sky like a firework display. But the pushiest parent of all is the squirting cucumber. A tiny vibration causes a spectacular show. Little squirts disappear into the distance like rockets. The next generation of plants are ready to start their own incredible journeys in an ever-changing world. But the problems some plants face are a mystery, even to the scientists who study them. This field of corn might look healthy, but it's in big trouble. It's under attack from a deadly rootworm, Diabrotica. The worms lay their eggs underground, and it's their larvae that cause the damage. They chew their way into the corn's roots and keep eating. Insecticides are the only things keeping these corn plants alive. But corn should be able to call for their very own animal protectors, just like tobacco. Something's gone very wrong.
It's just an olfactory leader experiment.
Scientists at the University of Neuchâtel in Switzerland run an experiment to show how corn used to be able to defend itself. 6 pots are filled with earth. 3 are planted with corn, the others with nothing. All are connected to a central container. One of the 3 plants is infected with diabrotica. The larvae immediately start to eat its roots. But unlike the corn in the field, this plant fights back. It releases a chemical cry for help.
So when the diabrotica larvae start feeding on the roots respond and they start producing a substance that's called caryophyllene. The substance is volatile and it spreads through the soil in the direction of this central pot where it arrives within an hour.
The final ingredient of the experiment has to be handled carefully. An injection of microscopic worms called nematodes. This is the army the corn needs. The worms are free to head in any direction, but nearly all go the same way.
So once they are injected in the central arena, the nematodes will respond to the call for help of the damaged plant by migrating in that arm. And we can find most of them in that arm after 24 hours and almost nothing in the other arms.
They might not look it, but nematodes are ferocious predators. They attack and destroy the diabrotica larvae. The plant's alarm call saved its life. It didn't need pesticides. This maze has lost the ability to call for help from the nematodes they need. Scientists don't know how or why this has happened, but the Swiss team are trying to unravel the mystery.
Now with our work, we're trying to reactivate or introduce new genes that make the plants able again to produce these signals.
They hope they can help the corn find its voice again. Until then, whole fields lie silent. Across the border in France, it's a very different story. No pesticides, just one man, his plants, and his music. Organic wine grower Jean-Marie Zer doesn't use fertilizers. He's convinced that what helps his grapes grow is a daily dose of the classics.
At first, everyone thought I was a little bit crazy. Some still do. But it's been my experience that the taste and aroma are better and the sugar levels rise.
Jean-Marie seems in total harmony with his harvest. He even has music composed especially for his plants. His work raises a huge question. Can plants hear? 2 German students hope to find out, with the help of the scientist's old friend, the tomato plant. The plants are placed in separate rooms and kept under exactly the same conditions, bar one. One group get their very own sound system. For 2 hours a day, they are blasted with classical music, whether they like it or not. Their neighbours are left in peace. Apart from the music, daily life for both sets of plants is exactly the same. The students measure them each day. 15 days later, time to test the results. The blue bars show the growth of the plants in the music room. They just pip their neighbours to the post. It's too close to prove it, but it's an exciting step towards discovering if plants really do respond to sound. And if plants are listening, who's to say they can't talk? In their own unique way, it seems plants can feel, smell, and maybe even hear. If scientists have their way, soon they could be able to talk too.
Hello?
I'm desperately in need of water.
Professor Wagner and his team get the conversation started. Monitoring electrical signals in plants could pave the way for them to find a voice. And that could be the answer to a farmer's prayers. Wine growers wage a constant war against fungus, which destroys their vines. Pesticides help, but if farmers don't spot fungus in time, they can lose valuable crops. So the professor and his team are developing an ingenious early warning system. These sensors react to changes in electrical activity produced when grapes are attacked. The sensors would be placed across the vines and electrodes wrapped around the stems. All would be linked to a high-tech telephone exchange. This way, vines could ring for help at the first sign of fungus. Their electrical distress signals would prompt emergency calls. The plants could interrupt the wine grower, wherever he was. The farmer could race to the rescue, thanks to a grapevine with a difference. Giving vineyards a voice is still a plan for the future, but some plants can already speak up and be heard. People often talk to their houseplants. Now, some houseplants can talk back. New York can be a fast and furious place to live. The pace of life isn't just tough on humans, it's tough on plants. People often forget to water them.
So that's all going on at the same time.
So science students at New York University have come up with a novel solution. When these plants need water, they can order it themselves. Plant pots are fitted with humidity sensors, which check the moisture in the soil. They're connected to a specially designed switchboard. If the soil dries out, the sensors set off the phone lines. Thirsty plants interrupt their owners.
Hello?
Hello, this is plant 09. I think I am very, very dry. Could you give me water so my soil is soaked? Very well. Thank you, thank you.
Hello?
Hello, this is Cuban oregano plant 09.
Hello?
Hello. This is the Scotch moss plant number 11. I'm desperately in need of water.
I don't know if it was you, but someone just watered me. It wasn't quite enough.
The experiment ensures the leafy residents at NYU get just as much liquid refreshment as the students. If plants can ask for a drink today, imagine what they might ask for tomorrow. Nature has equipped the plant kingdom with the most amazing skills. The ways they hunt for food, fight invaders, summon an army and spread their seed continue to amaze the scientists who study them. Plants are vital to us all. The more we understand what they are trying to tell us, the more we can help plants, and the more they can help us. Who knows what other secrets the undergrowth is waiting to share?